Cool, welcome for coming here at Tech Talk at night. First of all, I want to say if anyone has a question or anything that you wanted to ask, just look for people with this badge or this t-shirt, and we are here to help. Without further ado, I want to introduce you to the speakers tonight. We have Stuart, Engineering Lead at HubSpot, John, Director of Engineers at Phorest, and Olga, Tech Lead at HubSpot. And Stuart is going to talk to us about building systems that enable developers to succeed, and also about his haircut, which is very important.
Cool. Can you guys hear me? Awesome. And cool. So if you guys looked at the mailer that went out, the title was something like Patterns for Building, Maintaining, and Scaling Large Systems. And that was like originally the talk I set out to write. As I wrote the talk, it changed. And so this may seem like I'm talking about like very simple things, but these are sort of things that we have learned over the last few years that have helped my team succeed. It's helped my team succeed with like relatively junior developers, which I find to be like pretty awesome. Like it's easy to take a team of like kick-ass developers with like 10 years of industry experience and build an awesome product. But like when you succeed, you can't scale because you can't hire engineers with 10 years of experience. And so succeeding with junior developers and turning a junior developer into an awesome developer is something I'm very passionate about. And so some of the things I'm going to talk about today are lessons I've passed on that have helped me see people succeed. So start out with my haircut. I recently took a ski trip to Utah. I took a red eye from Boston to Utah and immediately went skiing. And I stopped for lunch, and this is what happened. It's turned into my Slack photo. People love it, so I'm sharing it. I've been at HubSpot now about 3.5 years. I started as a junior developer myself, and I've worked my way up to running a team of about 15 to 20 engineers. And if you want to reach out to me with any questions whatsoever, like just email me at Slayton@HubSpot or come find me after the talk. So HubSpot has a lot of things, and at the center of HubSpot is a product that we call the HubSpot CRM. If any of you are familiar with Salesforce, they sell CRM as a product, whereas at HubSpot, our CRM is actually much more of a database product. We are effectively the system of record for the entire product. Our marketing automation tools are built on top of the CRM. Our sales tools are built on top of the CRM. Our services tools are built on top of the CRM. And we have this single unified database for basically most of the product. To give you an idea of like what that actually boils down to, our system of record lives in a NoSQL store called HBase. We store a bunch of like database metadata in MySQL. We pipe everything together to keep our systems in sync using Kafka. And then we provide sort of like a real-time query view to our customers in Elasticsearch. To give you a sense of the scale of the system, our HBase storage are about 50 terabytes backed up. We're doing on the order of about 1 billion writes per day and about 10 billion writes per 1 billion writes per day and about 10 billion reads per day. This isn't like enormous like Google Apple scale, but like this is fairly sizable for someone who's only been in this field for a few years. Sort of one thing that what this talk is not is I'm not going to share super technical deep dives about how you can do like concurrent locks and deal with race conditions across like eventually consistent systems. Like if you want to learn that stuff, like just go buy this book. It's a great book. I basically give it to all my new engineers, and it's a really good introduction for building systems that have like really, really gnarly problems. Turns out most of our systems, even the really big systems, only have a handful of really gnarly problems. And if you can take those problems and you can encapsulate them and you can sort of abstract them away, you're able to do a lot of really, really cool stuff. And so if you want to know more about those gnarly problems, go read this book. So to give you some context of like the world that I try and succeed in, I tried to find out when my project was started, and the like SVN to Git commit goes back to 2012. There were already like several tens of thousands of lines of code. Now our code base is absolutely enormous. It's about 500,000 lines of code. And we run about 60 individual deployables in production. So this isn't like 60 instances of one web service. This is like 60 different Kafka workers, Hadoop jobs, web services, cron jobs. Like we just have a huge surface area. And I'm doing this, like we're running this with a team of about 15 engineers. So oftentimes you onboard a new developer, and I'll just like hear them muttering to themselves, like, what the fuck does this code even do? Like they somehow end up like working on a bug, following some like support request, and they end up in a world like they don't know what's going on. And to me, this is like a red flag, right? Like this is not a red flag necessarily the developer's bad. It's more that's like this code is not serving the developer. Like there's something wrong here. Another question that often comes up is like, how does the system even work, right? So it's like they may understand what an individual program does, but as you start thinking about distributed systems, you have to understand how your system fits in with the rest of the system. And that stuff is not immediately obvious if your systems aren't built appropriately. And so I've spent a lot of time working with junior developers, and I've isolated sort of 3 sources of pain worth talking about today. This is not an exhaustive list. I would love to hear if you have identified other sources of pain for junior developers. We could talk after the talk. Come find me. But the first one is like, when you have 500,000 lines of code, that is just like too much for any one person. We often have like Friday afternoons, like let's not ship anything parties where we go on a hunt to see who can find the most dead code. And it's actually a pretty fun exercise. It's a pretty effective exercise. We've cleaned out like hundreds of thousands of lines of just dead code, or code that is serving like 1 or 2 customers that really isn't valuable, and we can clean that out and reduce our tech debt. The next problem is this code is like really fucking old. So, like I said, some of it goes back to 2012, even older, like before Git is like prehistoric times as far as I'm concerned. And just like not knowing who wrote this code, why the code was written, what feature the code was for, if we have customers even use it anymore, like that makes it really hard to reason about your systems, right? Like if you have this really complicated algorithm that's consuming a ton of CPU, it's like if this isn't even serving customer value, providing customers value, like you should just kill it. But old code is sort of hard to know what's going on. And then lastly, because we're a distributed system, you don't have a complete view of what's actually going on, right? So we have a number of services that call into other services that then call back into us. And so it's like not uncommon for us to be alerted that service A is slowing down, and then service B slows down, and then service C slows down, and they all call into each other, and like the whole system just sort of grinds to a halt. And not being able to have visibility into these systems or understanding why they're slowing down is particularly painful. So like my developers just like don't know what to do in these situations. My junior devs don't know what to do. And so one of the things is like, I want to solve these problems, but I don't actually think these are problems that are even possible to solve, right? Like I cannot prevent context from being lost or forgotten. People join teams and they leave teams. People join HubSpot, they leave HubSpot. One of my favorite developers, I asked him about a PR he made just 3 months ago. I was like, hey, Matt, like, what was this PR about? And he laughed and says, I'm sorry, I have write-only memory, right? Like, even people who are top performers who are around, they forget why they do things. We're just all doing so much every day that it's hard to remember everything. Additionally, code bloat is natural, right? Like, you don't hire a developer to sit in meetings. You don't hire a developer to move tickets around in Jira. You hire a developer to write code. And so if your developers are doing their job, you're just naturally going to get more and more code over time. And this leads to the next problem where it's like big code bases are hard to understand, right? Like the more code there is, the lower percentage of it you can read, and people start duplicating features. People start re-implementing the wheel. And then the worst part of this is distributed systems have cascading failures, right? So like I said earlier, if your systems start calling into each other, when one service goes down, you can actually take down huge swaths of your product with relatively small bugs. And so what a lot of companies I've seen in my previous experiences do is they say, okay, you know what we're going to do? We're big enough, the stakes are high enough, we're going to slow down. And then you actually incentivize people not to do their jobs anymore. So like this guy, the snail, he's crossing the street, but he's just like taking his merry time. And I sort of feel like when you get to a point that this is the behavior you're incentivizing, you're actually starting to lose, right? Like you're not letting developers do what they want to do. You're not letting them write code. I mean, the company I was at before HubSpot, I left because I wasn't allowed to write code. It's like, why are they paying me if I can't do my job? So I'm going to tell you how I think you can make this work. But like, you don't have to take my word for it. Like, I'm just a dude who thinks he knows some stuff. I'm probably wrong. Come talk to me afterwards. So the first rule I give to my junior engineers is you're not writing code for computers. A computer will always do exactly what you tell it to do. What you should be doing is build systems that other humans can understand. And so to sort of give an example of like what that might look like, let's start with like a really simple toy web service, right? So I've got like some database, I've got like a web resource. I'm going to sort of pretend like everyone here speaks Java, but this should be like language-ish agnostic. And I've got this like one web resource that it serves GET requests, provides responses. It also serves POST requests and gives responses. But like this one web resource is like, it does everything. It's like a single class program. We've all written these. They're super easy to write. They're super simple. It's like when you're like trying to build out a quick feature, like just do it. But what happens over time is what starts out as a simple project slowly begins to bloat, and this web resource gets bigger and bigger and bigger. And all these validations and all this business logic just gets heavier and heavier and heavier. And what started out as a very simple, easy to reason about program, it no longer is like readable. It's like 800 lines of code. In fact, who here knows of like the encrypted messenger Signal? A few people? Cool. So there's so Signal is like an open source instant messenger that's encrypted. And it was started by this group, and some guy volunteered to build the Android app. And by the time like Signal officially took it over, the Android app was like 80,000 lines of code, all in like 5 files, and like nobody could maintain it because it was like this one dude's brainchild. And we want to avoid that, right? Because eventually someone's going to take over your code. And so the point I'm trying to make is like if you were trying to build a team that scales, if you're trying to build product that's going to be viable for more than a few months, you actually want to break down your problem into very simple pieces. And so we could change the sort of the get part of this system into something that a little bit more complicated, but something that's actually going to stay simple in the long term. So we have a web resource, and really all the web resource needs to do is take this GET request and basically like deserialize it from HTTP into some sort of like validated object. So in Java, we would have like a validated GET request. We verify that the caller's authenticated. We verify that they're calling against their account, like all this good stuff. And then we simply like create this validated request, and we're going to hand it off to this thing that I've sort of this comically named like a request translator. The request translator, it does one thing and one thing only. It translates the validated GET request into something that like our database or our database layer knows how to talk. And then the database, we have like a wrap around our database that it knows how to read this request and return like a maybe like an unserialized, a still raw database response. And then our translator, again, it could be the same translator, could be a different translator, knows how to take this response and translate it back into an object. The object is then provided to the web resource, and the web resource knows how to provide that back over HTTP. Again, like this is still like, for any of you who are like seasoned web developers out there, this is going to seem very, very simple. But having the discipline and the rigor to get your junior developers and to get you yourself when you're in a rush to build things correctly pays huge dividends. Likewise, like a POST request looks very similar, right? So we have the same translation layer that goes all the way to the database and back. But then the magic happens when we start needing to compose these systems together. So I've already got a GET request for reading, a POST request for creating. But let's say I want to support some sort of like patch operation or like a put operation. Well, I can take in a put request, I can translate it all down to this write request translator, and then by simply using the existing read request layer I have already, I don't have to build a second layer. I now have a single thing that knows how to read from the database. I have a single thing that knows how to write from the database. I combine them together to have more functionality than I thought I would need at the beginning, and the system doesn't get that much bigger. I'm not doubling the lines of code. I'm just simply combining systems together. And so when talking to junior developers about how do they build new systems, how do they think about designing architectures, we give them a few basic rules. The first thing you want to do is like break everything down into your logical steps. Don't think about the instructions you're giving the computer. Think about what are the logical things we need to do. And then for every step, define it as a pure translation. You know, if you're into like Haskell or any of the functional languages, like that's exactly what we want our developers doing. Like every translation should be a functional step. Take advantage of your type system. Sorry JavaScript, sorry Python. I used to love that stuff. Now that I have static types, I love it to death because I can define a type for every step. It may seem cumbersome and onerous, but it actually communicates to the next developer exactly what's in their hands. So take advantage of that. And then you really want to isolate your side effects. So anytime you're doing I/O, anytime you don't have a pure function, you want to put that in a single spot so it can be isolated from the rest of your code, and it keeps the rest of your code clean and pure and testable, which I'll get into in a few minutes. And then lastly, like embrace the single responsibility principle. Like this can be taken too far, but you really want every piece of your code to do one thing, to one thing really, really well, and it's the only thing that does that thing. And then what happens if you embrace that, then your developers will start to understand, it's like, hey, I need a thing that translates like a widget to a foobar. It's like, I know this happens everywhere. I'm not going to go write it. Like, I know someone's built it, so I'm going to go find it. And you can sort of prevent bloat by getting your developers to embrace these principles. So the other thing that is also very, very useful, in addition to designing simple systems, is documentation and contracts. If anyone here is from HubSpot sees this, they're going to be like, what? Like, we have a pretty strong don't write comments in your code. We don't do a lot of documentation per se as like a formal like procedure. But I'm going to argue over the course of these next few slides that we actually document our code very, very heavily. We also build contracts for our code. So if you think about, like, if you just entertain me for a few moments, if you think about what a document is, it's some sort of thing that describes what your program, what you think your program is doing. If you think about what a contract is, the contract is something that enforces that your program is doing the right thing, right? Like, if you have a way to know that your code is right, that's very powerful. You know, very often I'll encounter junior developers who do what they call like spray and pray. They'll like make some changes, they'll push it out, they'll test it, and it doesn't work. So they'll push some new changes, test it, it doesn't work. And they just like keep like trying things. And that's a really valuable exercise, but just don't do it on production. Don't do it in master. Do it in your own time. And so we want to protect our systems with contracts. And I'm sure some of you know where I'm going. This isn't going to be like, this isn't anything new and fancy. It's just a better way of thinking about your systems. And so the way we do this is we encourage very good test behaviors. So I don't always document my code, but when I do, it's using really good unit tests, or really good integration tests, or really good acceptance tests. And I can talk about what those differences are if people are interested. And so let's just sort of pretend like I'm writing a test for that read request translator. Like, this is a functional test. Like, the Java compiler will, you know, throw an error if this is not true, but this test tells me nothing, right? It says test reads. And so if someone comes to this test, it's like, oh, it's testing reads. It's verifying that the read logic is correct. And we can make some pretty minor changes that help communicate to future developers what's actually going on here. So I name this simply, it returns valid objects for validated GET requests that communicates to future developers what this thing is supposed to do. In fact, I was talking to another developer here at HubSpot who's like, hey, I just joined a new team, and I onboarded by reading all their unit tests. Reading their tests informed me what their core functionality did and how it worked, and I onboarded way quicker. And I think that is like the exact right way to do things. And so like really well-named tests, tests that verify the core behaviors of your system, buy you a lot. And so for like the write request, you would build a write request test with like this really great verbose name. Turns out in this meme economy, bytes are really cheap, so we can have really long names. And likewise for like the update request, you would, you know, do the same thing. You know, it generates a database write for validated put requests, and you would pre-populate all your inputs and assert your outputs and verify things work. So, but the thing I really want to drive home is your tests are your contracts. Every time a bug comes up, you know, you get a Jira or you get whatever bug tracker thing you get, and you go fix it. Well, it's fairly common, like a lot of really powerful developers I know will write a test before they even fix the bug that catches that bug. And the thing that's nice about that is, you know, these regression tests prevent the bug from coming back in the future in theory. And so you're not playing this game of whack-a-mole with your bugs over and over and over again. That test now guarantees, as long as the test is around, that that bug won't come up again. Like that is a literal contract you have with your code base. Here's a story that I'm sort of embarrassed to share, but like this is a unit test I ran into. I ran into this unit test about 2 years after joining my team. I was the expert on my team of this code base, and I looked at this unit test and I said, I have no clue what this is doing. I have no idea what this is like trying to actually verify. And so as part of a migration, I couldn't get this test to pass. I got every other test in the repo to pass. I couldn't get this test to pass. I was like, you know what? Like, I've actually fixed some bugs as part of this migration. This test is bonkers. And I deleted the test. And guess what happened? We had a huge regression. I was digging myself out of data Jiras for months, and the customers, you know, bless their hearts, were very patient with me. And the point was, some previous person had built this crazy safeguard. I still don't know what this test means, but there's a comment at the top that says, like, do not delete this test unless you know what it means. But this is the way that we can protect ourselves from causing catastrophic failure, right? And especially in these like larger systems where we don't understand the full surface area anymore. And so this is a principle I try and hammer into my developers. You know, a good test allows you to make changes with confidence, changes in a code base that you don't understand 100%. Bad tests give you a false sense of security, right? Like, I believe that I had sufficient test coverage, and so I deleted that test, and I paid for it, and our customers paid for it, and HubSpot paid for it. Whereas a good test, like, you can trust that you're not going to break things when you have good test coverage. So what makes a good test? First, a good test verifies outcomes. It verifies behaviors. It doesn't verify lines of code. There is definitely a place for like code coverage metrics, but the metric itself is not an end. It's simply a very, very leading indicator and potentially an erroneous indicator. And in an individual test, you want to verify as few things as possible. Like, I would say this test provides us coverage. It does like an enormous number of checks. Like, it's too complicated. That's why I deleted it. So what you should really do is break that test down into a number of tests that verify things individually. You want to mock your dependencies. You shouldn't be making API calls during like a test that happens at build time. You shouldn't be depending on other teams' code. You want to mock that stuff out so you can verify your local behavior. A good test should be easy to extend. It shouldn't be cumbersome to add new tests to a unit test. If you have to do that, you should fix your test harnesses. This one is sort of a fun one. A good test doesn't require refactoring. Like, if you're changing your code and you have to go rewrite your unit tests, you're effectively flying blind, right? Like, you don't know that your new tests are actually correct. And so if you live in a system where every code change requires a test change, there's like a leaky abstraction there. You should abstract them away and figure out how to make your tests not depend on specific implementation details. And a good test should be trustable. If it's constantly flapping, you're going to lose your future self's trust. You're going to lose other developers' trust, and they're going to either delete tests or deploy through them and cause problems. And lastly, this is sort of a no-brainer, but failures in tests should block the developer cycle. It should not be possible for a developer to push code out when they have violated the contract that the team has agreed upon. So wrapping up, like, there's no rocket science here, but if you want to help your team succeed, if you want to like take a junior developer and make them a rock star, focus on building simple systems. You want to focus on isolating that complexity, and you want to document and enforce what your code should be doing at a feature level so that you can guarantee that as you guys... Oh, man. There's a really cool slide after this, but it's not showing up. But basically, you can guarantee you can ship with confidence and not put the stability of your product or the trust of your customers at risk. Cool. Thanks. Damn it.
Does anyone have any question for Stuart? We might have time for one or two questions now, and then other later.
In terms of testing for somebody that is I'm a junior developer myself. I've been doing JavaScript for about a year, and I have no idea where to start. I've no shame in saying that, but it just hasn't been brought in to my sort of cycle as it's been sort of push a feature out now this week, next week, etc. So what advice would you give to a junior developer that wants to start, implementing tests into the next sort of set of features and components?
Yeah, so I think it's great that you're asking that question. I think that if you have just start reading online about what the best JavaScript testing libraries are. I don't know. I tried learning JavaScript like 6 years ago. I got scared away. I would... after, I can point you out at some people here who have some recommendations, but I would just start doing it. I would start simple, I would start small, and I would just experiment with trying how to write tests that are simple and understandable. Maybe pick a piece of your code that is particularly brittle and just think what are all the core features that this code must have, and then express those as a test and form that contract. and then just watch to see how bugs are caught, how bad releases are caught, and I would just start.
I was just going to ask, what do you think are like the top two things you do for the people side of this? Like, is it code reviews? Is it just making it like part of your pipeline to, do sonar or some sort of static code analysis to make sure that people are coding to design patterns or architectural patterns and writing the tests and so forth?
Yeah, so for the design pattern ones are hard because there's no programmatic way to catch those. And so with junior developers, we have a style guide that we send them to. We have like a few pretty cool like architectures that we say to mirror. But you really have to be involved with junior developers as they get started to show them like what are good behaviors and bad behaviors. And then as you're having your team meetings, as you're having your team gatherings, if you publicly acknowledge people who are doing the right thing, if you publicly acknowledge people who like went out of their way to like put in the extra work, I find that is very motivating to most junior developers. Just show them that they can do it, show that the people who do the right things will be rewarded, and then just provide a little accountability, right? So if a PR shows up that doesn't have any tests and you know it touches a brittle piece of code, say, hey, have you thought about testing this? How have you tested this? Can you guarantee this isn't going to take down production? Just like asking those simple open-ended questions gets them in the habit of starting to think that way. Because most of the time, like, they just don't remember to ask those questions.
Cool. Sorry, guys. Like, can you keep your question for the end so we can keep going with the agenda? Sorry.
Yep.
Next up is John that will talk to us about our scaling software as a service.
Hey folks, so that was a great talk by Stuart, thanks very much. So my name is John and I run engineering at Phorest. My talk today is about basically the 12 years we've been in business and the different stages our company has grown through. I'm really hoping actually that a lot of this comes back to Stuart's talk because a lot of it resonated for me there, and particularly as we grew from startup mode, trying to get product market fit to kind of get features, get customers, and then to actually grow the business and scale. A lot of the stuff he talked about there was really, really relevant for us. So I'm going to start at the kind of very beginning for us. So 12 years ago, essentially, Phorest wasn't really a company. It was a couple of guys in college. They had an SMS app that they used to drum up some business for nightclubs, for construction companies, and wasn't really going anywhere. So our CEO went and worked in a hair salon for a few months to get some cash. And essentially what he figured out was that if he used that SMS engine to text people before they come into their appointments, that they'd actually show up and actually save the salon money. Because if a stylist is standing there waiting to cut someone's hair and they don't appear, it comes out of the salon owner's pocket. So that was actually the early days of Phorest and how the company started. So the guys actually built this, which is probably one of the first appointment booking systems in the world. A Delphi app on-premise that had appointments, client management, and connected to that SMS engine to go and reach out to their customers. And what they locked onto was that they could help salons to run and grow their business and succeed. And it's a really special industry because you don't go into a salon thinking, oh no, it's not like a dentist. You're not going to rip out your teeth or anything like that. So you're going into to basically get a treatment and come out feeling good. So it's a kind of a special niche industry. And what we figured out was that if we focus on that vertical and build lots of functionality for them, it helps grow their business and ours. So that's the background. But as you can imagine, on-premise 12 years ago for a hair salon is quite, stressful for a hairstylist or someone who runs a little business in Roscommon to back up their data, or, imagine something goes wrong and like the data's on a PC somewhere and it's hell to manage basically. And also the fact that multiple versions of the system existed and just a real nightmare. So when we hit about 500 customers, we figured out, okay, how do we actually take this to the next level? And you're probably thinking that's digital bookings, so to be able to take that online. And you can't really do that when you're on premise because all the data lives in salons all over Ireland and the UK, which is where we were based. So we figured that we needed to build cloud backend and actually move those appointments and bookings to being digital. So what Phorest do is a salon software in the hair and beauty space. So we have a CRM, point of sale, and then we have apps which are powered by that cloud backend. So stuff like marketing, template, filtering, targeting customers. We have apps then for end users as well that let you book online. And we have like widgets on websites and stuff that let you book online. So from 500 customers up, we figured we needed to get it to be cloud-based. We needed to move to digital bookings and get away from being on-premise now. That was a huge challenge. It took us about 2 years to get away from that on-prem. We had to migrate a lot of customers. We had to let customers go. There was forks of the product that they were using that we customized. It was really, really hard. We used just the tech stack was actually so we're talking still like 8 years ago. We rebuilt that desktop app in Java Swing, if anyone has the pain of knowing what it is. So that Swing app talked to a cloud backend, which was built Java Spring on AWS stack, WebSocket to update terminals when things changed, all on MySQL. But the decision back then to stay with Java Swing was essentially that web technologies weren't great in really, really terrible rural areas around Ireland and the UK. And I'll talk about that a little bit later. So at 1,000 salons, this is kind of what happened. There was a lot of fires. Essentially, we got all our customers across to the cloud backend, but stuff started to fall over quite periodically. It was still pretty small, like in terms of the development setup, like 5-6 engineers all working in their own little silos, trying to get features done and just try and keep the place ticking over, get new customers, losing money. We were bootstrapping as well, so we were just continually fighting. Essentially, the solution was here to load balance the salons at a URL level. So the types of issues we were having were like JVM, garbage collection, stop the world events, database contention, lots of nastiness happening. And you can see up here you've got like the online bookings, the point of sale, and the branded apps I mentioned. They were all using that cloud backend. So this is kind of what it looked like in the engineering room at the time. Lots of fires. We couldn't really work on product. We wanted to build features, but we were firefighting all the time, and we weren't big enough to really handle it. We kept going and going, and that decision to load balance at a URL level definitely stung us. So, there was things like the customers knew there was a problem before us. There was a lot of issues around just like staff in the company answering calls to pissed off customers who couldn't book an appointment or make money through their system. So if you could step into their shoes for a second, you're trying to do a hair treatment and you're trying to look up, what color did they use, or do they have any allergies, and you can't because something's fallen over. It's the engineering team's problem, and it was pretty awful. So when we hit 2,000 salons, it was kind of like a decision to add another silo and take all this, those silos were really big, really expensive to run. Drop another silo on, keep firefighting, or try to grow up a little bit in terms of our engineering practices. And it's kind of like what I mentioned about Stuart's talk, is like we've got product market fit and we've got customers, and now it's like, let's get to the next level. And for us, we called it Project Darwin, which is why that picture's there, about kind of the evolution. And for us, we wanted to make the system more scalable, make sure that we could actually know that issues were happening before customers, that we were more confident in how we ship software, get those builds down, and really push the onus on the engineering team to own what we ship and use basically better best practices and continue to have more, more of a continuous improvement mindset, rather than like restart a server when something goes wrong, look at the issue properly and fix it. Again, I'm not going to try to be the expert on this stuff. Great book here to read if you want to know more about continuous delivery, how to get there, how you can get to a point where you can ship experiments, features, functionality to production reliably and repeatably. So it's all good stuff about your infrastructure as code, having lots of different types of test layers that we mentioned earlier, and just being able to repeatedly ship. So rather than once a quarter, why not 20 times a day? So coming back to the things that we had to introduce, we needed to be able to have really good automation around things before we could go actually changing anything majorly. So that involves bringing a CI server to life, bringing back any old tests that were disregarded, either deleting them or rewriting them. And then looking at the different levels of testing. So obviously unit and integration level tests, but then API tests so that we could actually test our APIs, change stuff in the background and make sure stuff still worked, particularly around removing caches. We use Gatling for performance testing. It's a really great tool written in Groovy. So basically simulating our requests for fetching appointments, customer data, and running those scenarios so that, again, testing stuff didn't break while we made changes. Cypress we used for a lot of UI testing, which was actually really good as well. So if you fancy checking them out, I would recommend it. So the first big job was to remove state. So for anyone familiar with the Java world, level 2 caching, you can't become scalable if you've got caches, particularly customers hitting particular servers, because what would happen is you go and fetch your appointment, and depending on where the load balancer brings you, you could get different version of the data, could be stale. So we needed to get rid of them. So essentially we had to, before we could do that, we removed the caches, and we realized that the database couldn't handle the actual requests without the cache. So we looked into a bunch of different options. Aurora for us was like just about becoming generally available. For anyone who doesn't know what Aurora is, it's essentially Amazon's rewrite of the MySQL engine using their own data layers. So it's much faster IOPS, and it scales automatically. So if your disk space is running out, you don't have to get an alert on CloudWatch and go and scale up. It just does it automatically. So it's awesome. And with our performance tests in place and Aurora switched, we knew that we could handle the load without the cache. VPC, so that old system was all deployed in classic Amazon network. So for us to be able to use like latest generations EC2 instances, get costs down, to be able to actually use Aurora because it's only available in VPC, you need to be there. So you also get lockdown security and really tight control of what data comes in and out. One really good tip for anyone who's trying to do this stuff is there's a thing called a classic link. So if you're breaking your system down into different components, moving them over to the VPC, you could maybe move a small component across and then do a classic link. So you could actually talk from your old environment into the new and gradually go piece by piece rather than like lifting the whole system across, shifting it over. Docker for us was really important. We had a big monolithic system. We had to break it apart into different pieces, different responsibilities. And with that, then we also had like different versions of Rails, different Java versions. Small enough engineering team as well, so we were about 9 at this point, and we wanted to make sure that we had a development, staging, and production environment that would be consistent with just some different environment variables, and it also just made the application much more portable. So we essentially build our images through the pipeline and deploy them. So. For us, Docker was the answer there. We used Amazon ECS for container orchestration. Really early adopters, actually, I would say, of that. So if this was before Terraform had even come up, before any of those really nice, even before Kubernetes. So 2,000 Salons, it looks a bit nicer. There's no fires. We're growing really well. We're able to focus on our product work. We don't have to derail ourselves. We've got this nice system with, instead of those big servers I showed you before, we've got one URL for every Salon. And essentially, it load balances between 3 EC2 instances, and each of those instances houses a Docker cluster. What's really cool about ECS is it listens to the health of each container, and if one of them dies, they'll get killed and brought back to life. So it's self-healing based on its health checks. It does really great rolling deployments. So before, it was our CTO's job to do deployments with a lot of manual stuff. So ECS will do a green-blue deployment. It'll take down, like basically drain connections from your load balancer and deploy them. Really, really great integration as well with IAM. So if your system needs to go to S3 or Dynamo or RDS, your containers have permissions to access them. So really, really neat. And if you want to chat about that afterwards, I can share you in on it. Infra as code. So coming back to continuous delivery, this is what a sample service looks like for us to deploy. This one is responsible for auditing things that happen in the system. So you can see, like with a few lines of YAML, you can essentially spin up a new service. So here we've got a container in development environment. It's just the latest image. It's not internet facing, so it's in a private subnet. We want to access S3 to get some content. For production, we want two containers, not one. So ECS will listen to that, and if anyone dies, it'll bring them back to life. Shipping frequency. So I mentioned like once a quarter, but we got to like 10, 20 times a week easily with back-end components, and then throughout getting further web interfaces to going, which I'm going to talk about in a second, it's spiked a lot. So our cost was really well under control at this point as well. So in 2016, we hit about $10 per Salon, and that would have kept going up if we hadn't have done the scaling work. So you can see then, you know, in 2017 and 18, we're at 4,000, 5,500, and the costs are much more stable and predictable. So things like knowing how many instances we need and auto-scaling. So we can do auto-scaling for busy times of the day or the week. So for example, on Monday morning, there's not many customers, the hair salons don't open, so we can scale down, but we can scale up on busy days like Friday. So like where we are today, at 5,500 salons and where we want to go to. So there's a few things that we're working on now and kind of directions that we're leaning to. So hopefully you get some insights into this. For us, web, it probably seems pretty obvious, but I mentioned Java Swing before. We can't really at scale ship software into salons and deal with all of that mess around firewalls and passwords, and we want to get away from being on native code. It seems pretty obvious now, but it's where we need to be, and it's a big job. There's 12 years worth of functionality there. We need to replace, rebuild, rethink. So getting away from native. So we have native Java and Android apps, Android and Swift apps for our branded side of things, and then Java Swing for the point of sale app. So where we're going now with those native apps is to React Native and Code Push. So 5,500 apps for iOS, then Android, you're up to 11,000, and that's right now. Where we want to get to is say 12,000. So it's a lot of apps. So if you imagine, we've got a really good CI pipeline behind those native apps, but still to push a bug fix for 12,000 apps takes a bit of time and a bit of horsepower on our Mac Mini. So we don't really want to go there in the future. And then on the point of sale side of things, we've embedded Chromium inside the Java app. And what that's allowed us to do is piece by piece gain control of the Swing app and start moving it to being web-based. And for us, our choice was Ember. React Native for us means a lot of really good things. So we've got a unified code base. We've got tools and testing that are consistent between both platforms. We're not chasing our tail, doing everything on Android first, then going back to iOS or vice versa. Unified language. We've got web engineers that can come across and pick this up quite easily. And we've got no platform limitations for what we want to do, which is essentially a booking flow, rebooking, some nice stuff like that. Code Push is really good for us because instead of having 12,000 binaries in the App Store, we've essentially two, one for iOS, one for Android. And if we want to do a bug fix for all of those, say, 12,000 apps, it's literally two builds, and that's it. Shipping is gone way better for us. So for our Ember app, it ships at least 20 times a week, and you can just see the feed. It's very annoying because it just keeps coming up every day, but the guy's continuously shipping in small little pieces. Particularly every pull request goes to production behind a revision key that allows product owners, stakeholders to see the stuff before it even goes live. We're able to use feature flags to handle rolling out, rolling back, and also we can roll back really, really easily. So this is amazing for us. This is just a quick peek at what like that old Swing app looks like with web interface. So it's a big, big difference. I wouldn't even like to think about how to try and build this in Java Swing. It would take 10 years. And also we're able to control our new React Native apps through a really nice interface and get previews and stuff. Just impossible to do with the old technology. Serverless. So we're looking at serverless now to manage costs, make sure that we're able to keep ahead of ourselves and not have to do this big Project Darwin again where everything gets too clunky and we have to stop. And our serverless is that for us. So if you look at serverless, it doesn't mean you don't have to think about servers anymore. It just means that you have to think less about them. And they're kind of functions as a service. So I think that's what they really should be called. So this is just how we're using them. So typically our serverless apps are an endpoint triggered by API gateway, which goes to a Lambda function. And the Lambda function might go to a DynamoDB or an RDS or an S3 bucket. What the serverless can do as well for us is react to different events throughout in the AWS environment. So it can pick up, you can invoke a Lambda function based on an S3 event, an insert into a table. And that's really amazing for us. Our main use case is actually SMS sending. So we send about 4 or 5 million SMS a month. And it's really bursty behavior. It's not something that sits there all the time and is continuously sending. People send marketing campaigns once and they don't do it again. So Black Friday is actually one of our busiest days, lots of crazy special offers going on. And our old legacy infrastructure was something we knew we had to rewrite for a long time. It is actually the app that the guys built in college 12 years ago, and that's what we had to replace it. So it was only capable of sending 15,000 SMS in a minute. So that's getting the request, processing, batching, and distributing off to the SMS providers. And Black Friday, the Grow team, everyone is really stressed about this because, are we going to get all these messages out on time? What if they fall to tomorrow? It's going to be all a big mess. So we knew we had to do it before Black Friday 2018. And when we look at Lambda, you can scale it essentially number of concurrent requests you want to handle. You don't need to even worry about it. So for us, we went from 15,000 per minute to being able to handle more than 100,000. And not even blink an eyelid really to noticing the scale it was doing. So over 4.5 million sent that day. What was really cool is the cost. So that old PHP piece of shit was running, cost $600 to actually to host. And the serverless says, I just checked that the AWS bill was $30. It's just unbelievable to have that scale and not actually have to worry about it. So yeah, it's kind of food for thought for you. What is your challenge? What phase are you at? What kind of things does it come back to some of the things Stuart mentioned in his talk? Some practices that you're missing. Maybe it's some future technologies that you maybe need to start thinking about. But just some food for thought. And if you wanted to chat to me about any of that stuff, feel free to. There's a conference on in September talking about a lot of this stuff. If you haven't heard about it, you can check out the website. So lots of stuff on serverless, cloud computing, all of that good stuff. Check it out. That's me, John, and thank you.
As before, yeah.
Thanks. First, I just wanted to thank you because my barber uses your booking system and it's so much better than the phone call.
Thank you.
And the question is, you mentioned you broke your monolith code into microservices or just services.
Yeah.
And what are some insights you could share about that? What you wish you knew before you started that?
So it was essentially a big Java app, but the best thing I could say about it was really well built. The foundations were really well set out. So the guys had actually broken it into modules and pre-thought of this stuff was going to have to be split out essentially before it had to be. Some opinionated but really good foundations are always really helpful. Here's one. So our approach was distributed monolith, so it was very much event-driven. So we were building services off the monolith based on events, and we used RabbitMQ for that. I would say if I was to go back, I wish I would have had to have paid for a hosted version of RabbitMQ and not hosted it ourselves. So we had spent a lot of out of hours time. You know, if you lose a dead letter queue, or you lose messages, you are fucked. So yeah.
Yeah, I was just curious your thoughts on React Native so far as the code base has gotten bigger and the app has gotten more complex.
Yeah, so to be honest, I've never seen a project go so fast. 2 engineers working on it, one way more experienced, one a junior. The speed that they've produced the Android and iOS parity has been amazing for me. They've spent a lot of time figuring out some stuff, and they've had to fork a couple of things. So there's definitely a bit of friction there around sometimes libraries not doing exactly what we need. But so far we've seen not much mess. One thing I would say is we flirted a lot with using GraphQL at the start, but we just felt that and Kevin's here as well, you can chat to him about it after, but we felt that it would just be another API layer to manage to make the React Native app a little bit faster development, but we didn't see the pure benefit over just using the REST APIs. So there's a little bit more code there to connect to the REST API and stuff compared to if you were using like Apollo client to generate all the code and stuff. So yeah, hope that answers your question.
Sorry guys, as before, if you can keep your question after the last talk.
Great, thank you. Cheers.
Thank you, John. And the last speaker for tonight is Olga for Global Search.
Wait, I don't need this. Hello. It's on? Yes. Hello, I'm Olga. I'm a tech lead at HubSpot, and I'm on the CRM team. Now, what is a CRM? The CRM is essentially your contacts app. And we've got this interesting problem where the contacts app is pretty much useless unless you can find your contacts. You know, if you have 25 Amy's and you type in Amy and you can't find the one you're looking for, what's the point? Or if you've typoed somebody's name, like, I don't know, all these different spellings or people just entering names wrong, you should be able to figure that out. Your contacts app should be smart enough to return the right thing. Or if you're typing like Elizabeth and you have a contact named Elizabeth, but then you also have somebody who lives on Elizabeth Street. Now, you as a human know that, like, okay, the name is probably more important. But how do you teach this to a computer? So we used Elasticsearch for this. Elasticsearch is kind of like a database, but it's optimized for searching. So it's not like a relational database where you can just like get things and whatnot. It's not like you're fetching something by ID. It's more like a glossary. So Elasticsearch is really good at knowing where everything is. So like, oh, winter. I know this is found in documents 1 and 2 and like 7. And then like coming is like over here and over here. And that makes it really good for searching. Also makes it really good for counting and aggregating. And if anyone's familiar with the ELK stack, it's Elasticsearch, Logstash, Kibana. That's used to like aggregate on your logs, view all this analytic stuff, and really process it. We're not going to do that right now because search is way more interesting. So on to the search part. When you search for something, you expect to get some sort of like list of results. And the ordering probably has importance. The first thing is the most important one. The last thing is not as important. So Elasticsearch has a score associated with each of these search results. And how it calculates the score is, for the most part, you can definitely change this. It's all customizable. It's this formula called TF-IDF. So TF is term frequency, so how frequently the term appears in that one document. And then IDF is inverse document frequency, so how frequently the term appears in all of your documents, every single document in your corpus. And the formula is TF star IDF. This kind of, you don't have to truly read and like calculate this, but it sort of encapsulates like how important each word is. So if all these like small words is the a, they're not going to be important because they're found everywhere. So just because you found a in this one word, in this one document, it's not that important. But if winter only appears in 2 of your documents out of like 10 billion, that's probably important. So as you're typing, Elasticsearch will calculate this score, and it will do this in a more human manner, I want to say, than like just your normal computer, like, oh yeah, I found this word over here. So now on to the actual searching. Elasticsearch has a RESTful API. So if you want to put something into your Elasticsearch index, an index is just a way to say a table. You do a post request, and say your document has ID 1 and your name is Amy Jams. And now you want to search for Amy. Now you just type in Amy because it's a contacts app. I'm not going to remember her last name. And Elasticsearch is smart enough; it finds Amy despite you not having typed the exact thing. Perfect. Now onto something slightly more interesting. This time we're posting something with ID 2 and name Benoit Jams. And now we're going to try to get Benoit, but without the accent mark, because who has time for that? I don't remember how to make that on my keyboard when I'm typing from my phone. But no, Elasticsearch will not give you this person, because why? Well, to figure out why, we have to step back a little bit and figure out, how does Elasticsearch save this text? How does it analyze it? What is it doing behind the scenes? It has this notion of tokens, where each text thing gets broken up into chunks. So for example, and you can customize how it does this. For example, the whitespace tokenizer just breaks up by whitespace. So hello world is hello and world. And then you can get fancy. You can have this delimiting tokenizer where it delimits, so breaks up by special characters. So by colons, by slashes, by dashes, all that fun stuff. And then it takes those tokens and it applies filters to them. The filters can be both by token and by character, but I've just simplified this to everything. For example, you have the lowercase filter. It lowercases the whole text. You can have the ASCII folding filter, which takes all of the characters and folds them down to their ASCII equivalents, if such exist. You can have the HTML stripping filter, where it removes all tags that it can find. You can also have the stemming filter, where it takes the word and reduces it down to its base stem. This is really interesting. It has a lot of international versions of it too, because obviously not everyone's searching in English. You want to have all the languages accounted for. And then there's also the n-gramming filter. This one is probably one of the riskiest but also coolest ones, where it takes and it forms grams, so little substrings of your word. And for example, this is an edge n-gram, where it takes R and then RA, RAC, and so on. Or you can just have an n-gram everything, every single substring of every possible word. Again, it depends on what you're searching, what your search patterns are like, what your users care about. Now, an analyzer for Elasticsearch is one tokenizer and any number of filters. For example, the very basic analyzer has the whitespace tokenizer and two filters, lowercase and ASCII folding. This is a very simple, very doable search. This is easy to understand. Also, what's mostly important here is that the filter order matters. It will do it in that exact order that you specify every time. And Elasticsearch does this both on the input side, so the post request that you give it, it'll analyze that text, and also on the query side. You can apply different analyzers if you want on query and input side, but it's mostly, you probably should be doing the same operations because you want to retrieve the text in the same way. So for an example, this basic analyzer takes hello cow, where's the blender? Then it tokenizes by whitespace. Hello cow, where's the blender? Next, you lowercase. Hello cow, where's the blender? Finally, ASCII folding. Hello cow, where's the blender? Now, if we had done this in a different order, I don't think this one would actually change. But for other things, it definitely will change, and you have to account for that. And now searching with the basic analyzer. So again, it's just tokenizing by whitespace, and the filters are lowercase and ASCII folding. You put Benoit Jams in there, and you're searching on Benoit without the accent mark, and you actually do find him. And why is that? It's because behind the scenes, the tokens produced from Benoit Jams are lowercase, ASCII folded, and tokenized by whitespace. And so is this one. And those two tokens are exactly the same, and therefore it's a match. Now let's get slightly more fancy. We have this delimiting analyzer, which is still tokenized by whitespace, but this time your filter is word delimiter, lowercase, and then ASCII folding. Word delimiter is just a way to split on text. It's very customizable, as is everything. it can, by default, split on like the characters like colon, plus, minus, underscore, slash. It can also do like case changing, like McDonald will be McDonald. It can also do letter to number changes, so like TI-84 is TIN-84. And for an example, hello O'Neill's, where's the super blender? And then you tokenize that by white space still, so it's still the same stuff. But now you delimit. So the first filter is delimiting. Hello O'Neill, where the super blender? You'll notice it's split by the apostrophes. It's removed all the punctuation. It split super blender into super and blender, and it's removed the possessive apostrophe s. This is geared towards English language. There's plenty of other stemmers, or delimiters and stemmers and everything for every other language, but for the most part, Elasticsearch was developed for English speaking. Now you lowercase it, nothing interesting there. And finally, you ASCII fold. What's fun to notice is that hello O'Neill, where the super blender feels way less readable, way less legit than what we started with. But it breaks everything down to like the basics. So anything, and since you're doing this on both input and query side, this has a higher probability of actually producing a match because, oh, I don't know, if I did not delimit this, you would have to type exactly super dash blender. And I mean, what if I just typed in blender? I'm assuming that super is just, implied. But this breaks it down, makes it really easy. So for an example, we have this delimiting analyzer, and now we're going to post in O'Neill. Now we're going to, you forgot. I know it's like Neil something, and it's got like a prefix. I'm going to type in McNeil, because I don't remember. And this works. This totally works, because the tokens produced from the input are O and Neil, and the tokens produced from the query are Mick and Neil, and Neil is the same in both. Voila. Now this might not be exactly what you want. This might not be the behavior your customers expect, as we actually discovered recently, that sometimes you want to be more strict. You should definitely know everything that your delimiters, your analyzers, everything is doing, because it can produce unwanted behavior. You can increase your recall by a lot. So there's this fun balance of recall and precision, where precision is how good your search is, like does it find the right thing? And recall is how much other garbage did you bring back? Like, oh yeah, no, I found your result. It's like on page 20. That's not really helpful. Or like, oh, I was so strict that nothing came back. So it's a fine line. Now for the most glamorous of them all, n-gramming analyzer. We're still tokenizing by white space, but now your filters are word delimiter, lowercase ASCII folding, and then edge n-gram. So n-gram is, again, like it's producing substrings starting from the edge. And this is commonly known as search as you type. So as you are typing, if you're sending off those search requests, you need n-gramming. So for example, the original is olga@hubspot.com. Then you tokenize, nothing happens because there's no white space. Then you delimit, you remove all the special characters, you split on them, you lowercase them, you ASCII fold, nothing happens, and now you're edge n-gramming. And now you've produced all of these tokens. You have O, OL, OLG, OLGA, and then starting from the next token, which is HubSpot. This is a good example of you want to get the order right, because if you edge n-gram before, I don't know, delimiting, you're going to get something completely different. This is also one of those examples that you definitely don't want to be doing this on query side and input side. You only want this on your input, because you want to be doing this. This is expensive, and it's storage-wise, it's CPU intensive, everything. You want to do this once, and then as you are typing, you are already producing those n-grams. You are already producing those substrings. You don't need to then re-n-gram. So, as an example, you have this post with ID 4, name olga@hubspot.com. You start typing. You only got to OLG before we fired off the query, and it's already there. You didn't have to type that long. One of our analytics is actually how much do you have to type before we give you the right answer. Where people are pretty impatient. You should not have to type out all of everything. You should not have to even reach the @ sign. You should be able to return the answer. Oh, and this is because Olga at HubSpot.com produces the tokens, O, OL, OG, OGA, and BAM, that one, which you can use any sort of analyzer for this. Probably just the delimiting one is fine, or even just the lowercase ASCII folding one, and because your token is right there. Now this is all fine and dandy. We simply did not answer all those questions that we had in the beginning, which is why a dash of machine learning. This wouldn't be an engineering talk without that. To solve the answer of the one Amy, the one true Amy in the sea of Amy's, you can have all of this fancy analyzing you want, and that won't answer the question. You need some more human touch there, because you know which one you want, and if given a list, you probably know that, like, oh, maybe it's probably the one I texted last, or the one I recently created. So you can tell Elasticsearch, yeah, sure, do all this fancy NLP stuff, but also recency. This is used in every single search app. Basically, you can tell Elasticsearch, yeah, the score that you have is perfect, but also incorporate recency. Have a boost, maybe some sort of decay function on how recently your contact was updated. And it will take that into account. And you'll see, okay, if all the Amy's had the same score, but this one was updated more recently, it's going to be at the top. Your customers are going to be happy. Now for typos, fuzzy matching. This is just a way to say oh yeah, I want an edit distance of 1. So I want to have one step away from the true answer. You can have an edit distance of 2 or 3 or however many you want. Elasticsearch has this natively. It's just a simple setting. Now, field weighing. This is Elizabeth versus Elizabeth Street. You know as a human that some fields are way more important than others. And you can tell Elasticsearch that, yeah, sure, search on every single field I have, or search on name, email, phone number, whatever. But then name is more important, and then maybe address is later, and then phone number is not as important. You can tell it times 5 this, times 3 this, times 1. Works. Now to get a little more into the weeds, how to do field weighing is you can use learn to rank and logistic regression. So learn to rank is essentially a machine learning way it tells you which of these fields is more important. And then logistic regression just tries to draw a line of best fit, and it'll tell the coefficients of that line will tell you exactly which what the weighings should be, what the weights for each field. For this to work, you need to have an analytics pipeline. So if you have your search and you're just blindly firing it off and answering queries, you can't do this. You need to know the answer. So oh yeah, this query, customer clicks on it. Now you know the answer because they clicked on something. So you know that now whatever it is you showed them, this is how it performed and this is how it should have performed. You want whatever they clicked on to be first. So if they clicked on last, nope. Tell the model to retrain. To get even more into the weeds, entity extraction. This is a way to take the query and pre-process it before it even reaches Elasticsearch. You're going to be okay, red couch. Maybe run it through some Stanford NLP stuff. You know red is a color, you know couch is a type. You can tell Elasticsearch, don't search on red the type. You know red is a color. You can tell it to only search on these fields, thus producing better relevancy, weeding out all this extra random garbage. And then embeddings. This is, if you could take every single document, say you have a HubSpot, and you could go and tag it oh, marketing, technology, all this stuff, that'd be great. Because then you could search on any of those related things and it would come back. But you're not going to go do that. Nobody has time for this. It's also mostly user-generated stuff. So instead, you take your corpus, all of your data, and you feed into this model, and essentially everything in one document is assumed to be related. So if you've got this article about HubSpot, it assumes that all of those words probably have some sort of connection. And if you have this document on best hikes in Dublin, those words also have connection. And it produces this graph where each connection is how strongly connected things are. So hiking and HubSpot, probably not very close. But then hiking and, I don't know, polls, probably way closer. And that way you can enrich your data. You can take this and put this into your data. And that way if somebody's searching, maybe I didn't put polls, but I put sticks. Oh, that's probably, that's close. And that way you've gathered extra metadata without really having to do any manual labor. Now, all that aside, I'm going to piggyback off of the previous two presentations and say test everything. Because Elasticsearch and all of this stuff is, you can be as fancy as you want, but unless you know that what it's doing is exactly what you want to do, unless you have the analytics pipeline, you can be like, oh, click-through rate went up because of this experiment. Or, oh no, like suddenly recall is massive for this one user group. It will be completely useless. You will be completely flying blind. There's no, Elasticsearch and all these analyzers do not do anything that is immediately obvious. So you have to have all these acceptance tests, all of these, analytics, data, numbers for this to all work. Thank you. That's all I have.
Hi. Want to say learn to rank and logistical regression. What stack of technology you are using over there?
What stack? Yeah. We have a machine learning team for this. Some of them are here today. For logistic regression, we took our pipeline data, we ran it through Spark, and we pieced together everything because like clicks are asynchronous to like searches, and we pieced that together and then fed that through the model that we were provided with, and then it spit out some numbers.
Thank you for the talk. Search relevance tuning, it's a pretty tricky job. Do you have some sort of tool to check the correctness of the search when you change a weight or an analyzer? So you can immediately have in the feedback loop, that you are breaking, because sometimes it seems that you improve a search, but you are actually disrupting.
Oh, absolutely.
Do you have some tool to help you in this?
It's mostly like our analytics pipeline. So we know like when people clicked, on what position did they click on? Did they click on the first one, the last one? And how many letters did they have to type out? What was returned? If people just like abandon the search, that's bad. And then we use this to do a lot of A/B testing. So we'll roll out like a different mapping, a different analyzer, and see, oh, did this group perform better than this other group?
And do you use also metrics around this, like information retrieval metrics like precision recall or other metrics, F metrics?
Yeah, we just send it's like the front end, so you're typing in and you're like, okay, 17 of these appeared, and we send them off to through Amplitude, and then we have a Spark job that reads from Amplitude and calculates all this.
Okay, thank you.
So, thanks. Two questions. What do you use for fuzziness? So, which kind of distance? Do you use Levenstein or something similar to calculate the distance? That's the first question. And the second is, regarding synonyms, do you expose synonyms to marketing in order to have them modify them in order to feed the index with different synonym based on the searches? Are they static?
What was the second question?
The synonyms.
Yeah.
So what we used to do is to expose the synonym files to marketing in order to be able to have them be able to modify the synonyms based on changes in the application or in the kind of search that were done. Do you expose those synonyms? Who manages the synonym lists or?
So for the edit distance one, in production we use an edit distance of 1 because 2 was too big of a performance hit, and we found that it actually didn't improve our numbers that much. So we're probably going to go build a different spell checker that's more complex than just this. And for synonyms, we haven't done this actually. But yeah, you would have to find a way to keep because the corpus keeps changing, and maybe like for each customer it's different. So maybe your contact list is mostly in French and my contact list is mostly in Spanish, and that's going to be a completely different web.
I wanted to say, like, whoever asked the question before to Stuart or John and want to ask the question now, like, you have time now. And also, we'll hang out later and you can ask the question to them directly. So do you have more questions?
So you mentioned, who was talking about? Yeah, about Lambda serverless. So you were mentioning about lambdas accessing, so not stateless, right? It's stateful, so accessing database. Did you have? So I know that with lambdas you can scale how you want, but then you have some kind of resources like connection pool that can leak. How were you able to handle that? I mean, in case of connecting to database, because obviously if you scale a lot, then you don't have enough connections.
We actually emit events from the Lambda function to go and do exactly
Got it. Thanks.
Yeah, regarding the graph as synonyms again, are you guys using some kind of linked data technology like semantic RDFs, this kind of stuff, or just a graph database that you guys figured out yourself how to build it?
So I confess we haven't done this in production yet. This is an idea that I had read about and I really want to explore later. So I don't have an answer.
Yeah, so this question is for John. So I know you were mentioning the approach for moving towards a microservice architecture. So I don't know if you mentioned that already or if I missed it, but how was your experience dealing with distributed tracing errors? So like, you have a microservice that serves this kind of context, and then you have other systems as well. And then how was your experience dealing with distributed errors and like alerting and things like just contracts in terms of how much of error rate can you handle and things like that?
Yeah, so we use Spring Cloud in QP has Sleuth as a distributed tracing, so we can trace from HTTP request to a message to another microservice, and then we use the difference between log entries and other like tracing solutions to see the flow. If that makes sense, but it's not easy. Yeah.
So my question is for Stuart. The company I'm working for right now has about 35% of code coverage for unit tests, and we are demanding from the business like managers to change the whole stack of the code base, and they are saying that it should happen in the next 8 months. So after 8 months, not now, because we have a project that has more priority. Well, that's a typical thing that happens with business always. And so we have a really low percentage of code coverage, and we know that it's bad. We don't want to do that, but we want to also start with a new kind of high percentage with the new stack. But do you recommend, like, what do you think? Do you think we should keep writing unit tests, or just leave it as it is, and then after 8 months just start from scratch?
Is this on? Yeah. So that's a really good question. And it's sort of to repeat a little bit, the general question is like, you're going through a migration and your new system is not going to be covered by your old tests. Like, what do you do? This is a problem we face on a pretty regular basis if we're like constantly trying to migrate our systems. And so the way that we go about doing this is we basically try and come up with a common pathway that will exercise both code paths, and we figure out a way to, in production, exercise the old system in parallel with the new system, and then verify out of band that either the write would have been the same or that the reads would have been the same, and basically like feed all of those deltas off into a completely separate pipeline and build alerting and monitoring on that. And what you'll find is like the first time you turn on this like dual write, dual read verification system, like the world's going to blow up. But slowly over time, you'll chip away at the long tail of bugs, and eventually you'll get to a point where you're finding bugs in the old system that the new system has already fixed. Rewrite an entire code base, not knowing how big it is, seems very ambitious for 8 months. So I wish you the best of luck. But I would just encourage you to think creatively about how can you guarantee to yourself and to your peers that when you actually flip that switch in production, that there's going to be no hiccups, that there's going to be no downtime, that there's going to be no bugs, there's going to be no different changes of behavior. And the only way you can do that is by enforcing the contract that your customer sees in both the new system and in the new system, and verifying that it works against the old system.
Cool. Thanks everyone for coming tonight. Thank you to the speaker for the amazing talks. The speakers and us are gonna hang around a little bit longer in the kitchen area. Feel free to stay and ask questions or anything. Tomorrow morning, questionnaire for feedback will come out. Please do fill it. Tell us what we can improve, what we can change, what did you like and didn't like about the talk. And thanks again for being here.